Hey, what's up everyone? Brandon Lee with VirtualizationHowto, and today I want to talk about 5 DNS servers that every home labber should know about in 2026. DNS, after all, is one of those services that I absolutely love working with in the home lab from an infrastructure perspective. There are some incredibly cool and very feature-rich solutions out there for you to know about in the realm of home lab, and that's exactly what we're going to dive into in this video. So stick around and let's talk all things home lab DNS. I actually wrote an article starting back in 2023 covering some of the best self-hosted DNS solutions available, and I recently updated that article just a couple of weeks ago with DNS servers that I think in 2026 offer the best features and value. Since my original article in 2023, a lot has changed with that list. Even some of the solutions that I had on the 2023 list, I actually carried over and including in the 2026 list, but a lot has changed. Lots of new features, lots of capabilities. And one thing that I want to mention up front is that this is not really a ranking of these DNS solutions. Each of these DNS servers, in my opinion, solves a slightly different problem, has different strengths, different potential downsides. So instead, these are 5 DNS servers that I would seriously consider if I were building a new home lab environment from scratch today. Let's start with the DNS server that has become my personal favorite all-around solution for DNS, and that is Technitium DNS server. If I had to describe Technitium in a single phrase, I would call it a Swiss Army knife of DNS servers. It has an incredibly rich feature set. It supports many modern DNS capabilities that I think bring value to home labs and self-hosting. It supports recursive DNS, authoritative DNS, conditional forwarding, DNSSEC, DHCP integration, DNS over HTTPS, DNS over TLS, and many other features that would normally require multiple products or solutions to be stitched together, making a more complex solution. Before moving to Technitium, I ran Pi-hole for quite a while, and I absolutely love the Pi-hole web interface. One of the reasons I was initially hesitant to switch was because I didn't want to lose that polished management experience for the home lab. Fortunately, Technitium delivers in that area as well. The interface is modern, it's intuitive, and very easy to work with, and they have actually been adding additional refinements since last year. In the interface, you can easily manage your zones, records, forwarding rules, DNS policies. Everything feels very straightforward and intuitive. One area where Technitium really shines is in home lab environments that have become a little more advanced. So if you're managing custom DNS zones, split brain DNS configurations, Active Directory integrations, or multiple network segments, Technitium handles those scenarios, I think, very well. And it's also incredibly easy to deploy in a simple Docker container, which is how many of us prefer to run our infrastructure services these days in 2026. And if you're looking for ad blocking and telemetry filtering capabilities, Technitium can do that as well. And it provides many of the same benefits, if not all, arguably, that have made Pi-hole so popular over the years. The biggest development for Technitium came at the end of 2025 when native clustering was introduced. And for me, this was a huge deal and gave me really all the reasons I needed to switch away from Pi-hole. Before that, I was running multiple Pi-hole instances synchronized with Nebula Sync, and it worked, and Nebula Sync is a great community-driven project, but it added another moving part that had to be maintained. Now, once Technitium introduced that native clustering with the ability to cluster Technitium servers natively, it was a fairly easy choice for me to switch over from Pi-hole. And since then, it has become one of my preferred DNS solutions for the home lab. Now, next up is Unbound. Unbound takes a very different approach compared to something like Technitium. Unbound focuses almost entirely on being incredibly fast, and it's a secure recursive DNS resolver. It's not trying to be everything to everyone, but instead it focuses on doing one job exceptionally well, and that job is recursive name resolution. I've been a huge fan of Unbound for years because once it is configured, it just simply works. It rarely requires you to have to tinker with it or tweak anything, consumes very little CPU and memory, and it delivers on what it promises to do, outstanding performance. Now, this makes it especially attractive for lightweight systems, lightweight labs with fewer resources and environments where efficiency really matters. Unbound also supports advanced DNSSEC validation and can perform recursive lookups directly against root DNS servers instead of relying on public DNS providers. So for privacy conscious users, that's a very compelling capability because it allows you to really keep more control over your DNS resolution process. Now, another thing I really appreciate about Unbound is how well it fits into an infrastructure as code workflow. Running Unbound in Docker is extremely straightforward, and because its configuration is a simple file, it works beautifully with Git repositories and something like a CI/CD pipeline. In my own environment, I keep my Unbound configuration stored in Git, and deployment is fully automated through my pipeline processes coming from GitLab. One challenge with Unbound is that it does not provide native clustering or configuration synchronization like Technitium. So we're back to some of those challenges that something like even Pi-hole has. Initially, I thought this would be a significant drawback when I was looking at Unbound. However, I eventually realized that my GitOps workflow had already really solved the problem and I just wasn't looking at it in the right way. So instead of needing clustering, I simply just needed to add a second deployment target in the CI/CD pipeline that I already had. And then when the configuration is changed, it is simultaneously pushed to both Unbound servers. So now I can have a proper primary and secondary server. Now, it's technically not clustering, but from an operational standpoint, it provides the redundancy in my home lab environment, and that is a conditional forwarder. Now, the next DNS server on the list is Bind DNS, and specifically Bind 9. This is probably one of the most iconic DNS servers on the list because Bind really has been a foundational DNS solution that has powered the internet literally for decades and enterprise environments around the world. So if you want to learn traditional DNS administration and understand how enterprise DNS infrastructures are designed, Bind 9 is still one of the best platforms available, and you can easily run it in the home lab in a Docker container. Now, Bind feels very different from solutions like Technitium and Pi-hole because it is heavily configuration driven, configuration file driven, but it honestly feels like a tank when it comes to DNS servers. You're working directly with zone files, authoritative DNS configs, reverse lookup zones, replication. There's no polished web interface. You're going to configure and edit config files manually. You're going to validate your syntax and manage your DNS infrastructure at that lower level. Now, that's what makes Bind especially powerful and flexible. It allows you to have that primary and secondary DNS server, has the ability to do zone transfers between the servers, hidden masters, traditional replication models, and virtually any advanced DNS configuration or architecture that you can think of. There's probably a way to do that in Bind. Now, in many ways, it remains that gold standard, I think, for learning enterprise-grade DNS concepts, especially with Linux servers and Linux hosting. Personally, when I compare Bind and Unbound, they are similar, but yet they serve slightly different purposes. Unbound is lighter, it's simpler. Bind is much more feature-rich and flexible, but that additional capability comes with more complexity. So if I need simple recursive lookups, I'm probably going to choose Unbound. But if I need those enterprise features, I'm going to lean more towards Bind DNS. Now, next, let's talk about Pi-hole, which has become almost a household name in the self-hosting and home lab community. Many people actually discover self-hosted DNS through Pi-hole because it combines DNS functionality with powerful ad blocking and network filtering. And that's usually what people are Googling and trying to find when they stumble on Pi-hole. Then they discover the DNS capabilities that it offers. Now, it's easy to deploy, easy to manage, delivers immediate benefits. Just in a few minutes, you can literally start blocking all of the ads and network telemetry that cloud hosters are trying to capture from your network. And over the years, I've deployed Pi-hole many times. One of the things I always appreciate is just how quickly you can get up and running. You gain valuable insight into what devices are using your network, what domains they're communicating with. And one of the things that I think makes Pi-hole especially useful is that it works extremely well alongside other DNS servers. In fact, I did a video some time ago how to integrate Pi-hole with Unbound server. The primary weakness, I think, of Pi-hole has traditionally been the clustering aspect. So unlike something like Technitium, you don't have native clustering. You're going to have to rely on something like Gravity Sync, which was the legacy 5.x branch of Pi-hole. But now Nebula Sync is the solution for Pi-hole version 6 and newer. So you want to look to Nebula Sync most likely if you're interested in Pi-hole. So Nebula Sync can synchronize those groups, the clients, the DNS records, configuration, allow listing, block listing, any of that you want to do. So it's not true clustering, but it gives you that very similar experience so you can maintain redundancy. A lot of times people will run 2 Pi-holes, have Nebula Sync synchronizing that configuration, and then they'll have a keep alive virtual IP that runs in front of both of those Pi-hole instances, so that literally if one node goes down that's a primary, it's automatically going to fail over to that secondary, and it's going to be a lot more graceful most of the time than primary DNS server and a secondary DNS server. Now, finally, let's talk about CoreDNS. CoreDNS stands apart, I think, from the other DNS servers on this list because it was a DNS solution that's designed specifically for cloud native environments. And the reason I include it on this list, if you're running Kubernetes today in your home lab where you're looking to run Kubernetes, there's a very good chance that you're already running CoreDNS, whether you realize it or not. It serves as a default DNS solution for most Kubernetes distros, and it plays a critical role with things like service discovery, pod services, deployments, applications that rely on domain name server lookups to query services. So without CoreDNS, Kubernetes simply would not function the way that we expect it to. Now, what I find fascinating about CoreDNS is that high availability is handled very differently compared to traditional DNS servers. So instead of implementing clustering directly within the application, CoreDNS relies on Kubernetes itself. So you've got multiple replicas that are deployed across your Kubernetes hosts and Kubernetes services, and the Kubernetes control plane handles the scheduling, the scaling, the failover, and resiliency of CoreDNS. So it truly is a cloud native approach that builds on top of all of those features and capabilities of Kubernetes and that it has natively. Now, as more home labbers embrace Kubernetes or GitOps workflows, cloud native infrastructure, I think understanding CoreDNS becomes very important. Outside of Kubernetes, you rarely see CoreDNS deployed as a DNS solution, but inside Kubernetes, it's absolutely essential. Totally different story. Now, one lesson I have learned repeatedly over the years is that DNS redundancy matters far more than most people realize. So if you have a single DNS outage, that can effectively take down your entire home lab, even when every other service is healthy. What's interesting is that each of these DNS platforms approaches HA very differently. Technitium has native clustering. Unbound can leverage GitOps and automated deployment workflows. Bind relies on traditional DNS replication and zone transfers. Pi-hole uses synchronization tools like Nebula Sync. CoreDNS relies entirely on Kubernetes scaling and failover mechanisms. So as you can see, there's no universal answer here for the HA capabilities of DNS. The solution depends on your environment, the infrastructure that you're running. After spending countless hours experimenting with DNS servers across things like virtual machines, containers, Kubernetes environments, I have come to appreciate that each of these solutions, I think, has a place. If I were building a brand new home lab today and wanted the most complete all-around DNS platform, Technitium would probably be my first choice. For dedicated recursive DNS resolution, Unbound remains my favorite. If I wanted to learn and implement enterprise DNS concepts with Linux, Bind 9 is unmatched. I think Pi-hole continues to be one of the best ad blocking and network visibility tools out there. And if Kubernetes is part of your environment, CoreDNS is the standard. Well, I'd love to hear what you're running in your home lab. Are you using something like Technitium, Unbound, Bind, Pi-hole, or CoreDNS? Or are you using something completely different? Let me know down in the comments. And as always, if you enjoyed this video, make sure to like, subscribe, and hit that notification bell. Check out Virtualization How-To for home lab, virtualization, Kubernetes, and self-hosting content. Thanks for watching. Do stay safe out there. Keep on home labbing, and I'll see you in the next video.